In this video, we are going to give an overview of draw scaling. And I guess we need to begin with what exactly are we talking about when we say draw scaling. Well, and as far as a simple definition, draw scaling is simply a manner of rendering all of your screen elements off screen and then redrawing the final result at a different resolution.
That's right. In the end, this is just a way to deal with the concept of handling multiple resolutions in our game. So if you've got like a computer and you want to change the resolution because you have a larger or smaller monitor, or maybe you're outputting to a TV for like the Xbox 360 and you have to have 720p, 1080p, that sort of thing ready, how do you handle all those resolutions?
Right. Now, at this point, you may be wondering, well, wasn't that the purpose of screen res X and Y in our original configuration? Because that changes the resolution.
Well, the answer is sort of.
The problem comes in with actual item placement on any given screen. We're talking about screen layout with text and including things like actual screen items, game items, notes with tracks that have notes on them, and so forth.
Right.
And the problem would be best magnified by simply demonstrating some positioning.
In a way, we've kind of already seen the heart of it because we've placed a few things on the screen, such as our log, based on some pixels.
Right.
So what happens when the pixels change?
And that's an interesting question. If we were to jump in here and change it now, I believe the log is fairly adaptable. It's actually reading the screen res.
Right.
So it'll appear to just stick and adapt and morph.
But not everything will.
But exactly, if you have like a discrete piece of text that needs to stay the same size, obviously you don't want that stretching with the screen.
Right.
So let's give an example of just such a piece of text. Let's say that for whatever reason we wanted to place some text in the bottom right-hand corner of the screen. So let's jump here just for example purposes. We're inside of our main game class inside of the draw method. I'll jump in here right after we make our call to log.draw. And all we'll do is draw out a simple piece of text. So we'll grab our sprite batch, we'll tell it to draw a string. We'll draw that string using the small font. So we'll take style dot font small, and the text we'll draw will just be something like bottom right. Now for the position, I'm going to plug in some magic numbers into a vector 2, and that should jump us to the bottom corner of the screen. Because it's not the initial positioning that I'm so worried about, it's what happens when we change our screen resolution. So we're just going to drop in 790 by 650 for the example.
Yeah.
And for the color, we'll grab something that'll stand out, so we'll drop this in as color.yellow. So now if we run the game, then we should simply see our new text drawn here at the bottom right-hand corner as bottom right. So
Ta-da!
All very simple, just very basic screen positioning.
So everything's working so far. What's the problem?
The problem is what happens when we change screen resolution. For example, if we went up to our config XML file and changed to a more standard resolution of 800 by 600 and run the game, our text is gone. Or rather, our text is probably right about here, just off screen.
Yeah.
We can start to pull some of the resolution back in. If we did maybe 800 by 700, we now have enough height, and we can see just the edge of that letter B off to the corner.
This also brings up the background texture you've got there.
Oh, you'll also notice now we're missing the N on main.
We just have my.
So we've definitely got some positions more than just the items themselves, but actual textures that were designed to fit on screen. The moment we start sizing our screen around, we're just going to end up clipping all of those elements off.
That's right. The word main is actually supposed to be in the middle of that texture. So this is not getting scaled at this point.
So that's the problem that we need to address, the fact that we want to be able to position things in terms of exact pixels. That just makes it easier on our job so that we're not fighting, for example, with a floating point value and trying to decide exactly how many pixels 0.02 deals with. It'd be a lot easier to just know what our canvas size is and then know how much we're moving something when we move pixel by pixel.
Exactly. Now, Logan has given you a nice programming example of the problem. I am going to get out the whiteboard and give you a hand-drawn concept of the solution. Again, this is just a concept. Here's how we're going to do this. Let's say we have our graphics system that is functioning like a projector. So here's my projector. I hope you like it. And if you don't, well, I'm sorry, because later on I'm going to draw a camera that's going to look a lot like that. For future reference, if you see the slant back, that's a projector. Anyway, so here's how this is going to work. We're going to project all of our graphics onto an internal screen. Now, if you want to consider internal, here's a nice little line, and everything on this side of the line is internal, and everything on this side of the line is what the gamer sees or what the user is seeing. So this is the real world.
Exactly. All of that internal stuff is all behind the scenes.
So here's how this is going to work. We're going to project our game onto an internal screen that the user is never going to see. And this is going to be done at a set, agreed upon, hard lock resolution of 1280 by, was it 960?
Yep, that's right.
By 960. That's the size this is always going to be. So here's our game. For whatever reason, our game has a smiley on it. Now, the other part, the way we're going to handle changing this resolution, because let's say out here, in the really real world, our user is using a screen and they want to run it at, for whatever reason, 800 by 600. This could be any resolution in the world. It could be gigantic, it could be microscopic, whatever. We're going to pick on 800 by 600, which, strangely enough, is nice and smaller. It's almost like I drew those to scale. Here's how we're going to handle it. Again, this is all in concept. We are going to take a picture with a camera. So this is a camera. Of this entire rendering. So everything that has been rendered internally, we are going to take a picture of it. We are then going to output that picture. So if you imagine like a camcorder that is actually connected straight into another projector. And then that projector is going to output onto whatever size our user wants the game to be. So does that make sense? We're going to render all internally, and then we're going to record that as basically as a single texture, just like if you took a camcorder to a movie theater, which you should never do, but it's the same concept. Whatever is showing on the internal screen, we're going to record and output on a separate projector.
Let me throw out another analogy, a little bit closer to the world of computing.
Okay.
This is no different than if you saw a picture on your screen and you took a picture of that picture using print screen and used your favorite image editing software to size it down.
Yeah.
And now you're looking at that sized down version on the screen.
Which I do that all the time. This is just doing it on the fly every game cycle and doing it with your graphics card.
Exactly. So it's a similar series of steps where we've drawn a picture, we get a picture of that picture, and we redraw it.
That's right. Now, here's the only place where I'm going to try to throw you for a loop, because conceptually, this is all very easy to understand. I mean, you could actually set up a real-world example of this if you had a couple of projectors and a camera and the time, which I don't have. The place I'm going to throw you for a loop is this projector over here on the left and this projector over here on the right are actually one and the same.
Exactly. When we're talking about this in terms of what is actually making graphics, well, that's the graphics hardware inside your computer.
That's right. This is actually the graphics card doing this. So while from a concept it does make a lot of sense to picture these as two separate projectors, it's actually not. If you wanted to really get technical about it, in case there are some folks out there that are really wrapped up in the technicalities, what's actually happening here is that this projector is first projecting an image onto this internal screen, and then that's being captured and sent back to that projector so it can then project it out to the final output.
And for the sake of the drawing, you could almost imagine a projector on a swivel where he's turned to the internal high-res buffer,
right,
and he's told to render something. Then, via the camera and the video cable, he's turned to the final output, and then the camera is connected in so that he can render the output. So really, it's the same thing rendering both pictures.
That's my idea of a swivel. So there you go. It's a little swiveling table that just rotates back and forth. So step one is we would actually take a step one is we would actually project on the internal screen, then take a picture of it, and step two is we project out to the final output.
Exactly.
So that is how we're going to handle this. And of course, the upshot to all of this is that if we say, okay, if this is 1280 wide, if we pick on 640 and we want to put a circle that is centered up at least in the x-axis at 640, and what is that, 480 if you go the other way? So something that was centered up at 640 by 480 is dead at the center of the screen. So if we had a little sprite that we centered up right there, it would be at the center of the screen. If we use this method, then later on when we shift down to 800 by 600, it's still going to be in the middle of the screen. Because all we've done is take a picture of how that looks and output it at a smaller resolution.
Exactly, because at that moment of taking a picture, the act of taking our internal buffer and turning it into just a normal texture, at that point, everything's going to stay in proportion, because then we're now it's like we're re-rendering the whole screen as a single texture.
That's right.
So everything will stay proportional.
So that's how we're going to be handling this from a conceptual standpoint, and I think from here we're ready to actually start coding.